solve three integral questions from substitution method, partial fractions, and volume calculation by using double integrals. Firstly, we'll find the integral of 4x times the square root of 1 plus x squared dx. First, we have to find u, and we can easily see that it's equals to 1 plus x squared, and du, which can be easily differentiable, 2x dx. But if we have 4x, and we'll have to multiply by 2 du equals 4x dx, and our integral will look like 2 times the square root of u du. And by using the properties of integral, one of the properties of integrals, we'll open it up, 2u over 3 over 2 divided by 3 over 2. That means 4 over 3 times of u, 3 over 2 plus c. And then we'll have to replace u with the value we found. We find that 4 over 3 times 1 plus x squared over 3 over 2 plus c. Now we'll have to validate the result by taking its derivative. Then by taking the derivative, we'll write 4 over 3 times 3 over 2 times 1 plus x squared over 1 over 2 times 2x, and then when we make the final processes, we will see that the result will be equal to integral 4x times the square root of 1 plus x squared. Now let's go to partial fractions. It tells us to find the integral of x minus 5 over 2x minus 3 multiplied by x minus 1. Let's start by give two values a and b, but a will have the denominator of 2x minus 3 and b will have the denominator of x minus 1. And we multiply the denominators by to make them equal. We will see the result of ax minus a plus 2bx minus 3b over 2x minus 3 plus times x minus 1 will be equal to x minus 5 over 2x minus 3 times x minus 1. And then we'll realize that ax plus 2bx will have the same parameter of x, and a plus 2b equals to 1, and minus a minus 3b equals to minus 5. When we sum up the equation, a will be equal to minus 7 and b will equal to 4. Now our integral looks like minus 7 over 2x minus 3 plus 4 over x minus 1 dx. And then when we use the properties of integrals, we will see that the minus 7 times of ln 2x minus 3 plus 4 times of ln x minus 1 plus c. Now let's go to the final questions of volume calculation with double integrals. It tells us to calculate the area, calculate the volume on the surface z 3 plus x squared minus 2y over the region d defined by 0 to 1 and minus x to x. First, we will have to write the integral of v equals to the region D as the the function 3 plus x squared minus 2y dx dy. And then our integral will look like from 0 to 1 and minus x to x by writing the same function bx and by. Now our integral will look like this. From y equals x to y equals to minus x, 3y plus x squared y minus y squared. And then our integral will look like this. 3x plus x cubed minus x squared. And now we'll write subtracting from minus 3x minus x cubed and plus x squared. And then our integral will look like that. When we sum things up, it will go from 0 to 1, 6x plus 2x cubed, and when we do the final process, we'll see that the actual function will be 3x squared plus 2x over 4 divided by 4, so it's equals to x over 4 divided by 2. And when we add x to its initial values, we'll see that 3 over 1 divided by 2 minus 0 equals to 3.5, or 7 divided by 2.